The first setup for the GP-43 secondary operations. These are what the blanks look like here. And here's one of them. Here's the start and stop. Here's the spindle. Come in close and look inside here. This is the spindle here. There's my oil. This is the indexer. And this is the whole mechanism here. Is a single linear CNC controlled axis, CNC controlled indexer. And they'll feed back here to an Arduino microcontroller and two servo drives. And then this is plugged into my Dell XPS M1530 laptop running Ubuntu 12. And so I'll load one in. There's no collet, so I have to screw it down with a low profile button head screw and a Torx T6 drive. Okay, now the part's loaded in, and I can drop the spindle down. Now it's locked into position in parallel with the axis, and I'll start the spindle, which is a bit loud. Okay, this is probably the final video for this project, but I just wanted to make one more and show what I ended up doing. This is probably the system that I'm going to use to make 1,000 parts. I've already made around 200. There are a couple of modifications. One, I added this splash guard around here, and this one here, because I ended up losing a lot of coolant and getting sprayed in the face for a couple hours last time. I redid this electrical wiring, made it nice and neat, somewhat waterproof / resistant. I modified the transmission back here. These are pulleys off of a drill press that I machined down, and the RPM is much higher. One of the problems I was having last time was when the part was going past the blade, since the blade wasn't spinning fast enough, it was kind of seizing up. The teeth weren't moving through the metal fast enough, so it limited how fast I could produce parts. But now that I made this thing really fast, I ended up bringing my cycle time down to 1 minute, like under 1 minute, compared to 2.5 minutes, which is what it was originally. What else? The splash guard. I added this handle here. The transmission. I think that's it. Here's the control circuit. It's 2 lead shine stepper drivers and an Arduino. I'm running it off this power supply. And there's my stop and go button, which I'm going to put eventually into a nice enclosure. Maybe have a little control box over here. But not yet. So I'll fire it up. I have a blank part loaded in already. And I'll start it up. Those are the first 12 slots. Those are pretty deep. And then afterwards I have to do this manually, where I lift up the spindle with this handle and just shove an Allen wrench under there. I'll put down the camera for that. Eventually I end up making this CNC also, but for now I'm just going to run the parts like that. That's going to give me my spacing. And then when I press the go button again, it'll do the remaining 16 slots, 28 slots total. So I set this machine up in 2 days. It's made by Do More. It's an automatic driller. It works with pneumatics, but it doesn't need a compressor. I guess somehow it builds up its own pressure from the spindle turning and actuates the spindle downwards. And here's the indexer that I pulled off of the horizontal mill. So the same, it's just a servo. And then I put a live center on it. This has a ball bearing in it with this speed, this quick clamp. And again, it's running off the Arduino and a single drive this time. And here it goes. That brass post that you might see has a pin in it to index the part so that these holes go in the proper alignment with the rest of the grooves. Let's see if I can get a view of the part. Yep. I just wanted to demonstrate this temporary setup that I made to run a thread gauge through all these parts. I have an Arduino set up with one of Avan Electronics drivers, and those two are set up temporarily to drive this stepper motor. And the user interface is down here. It's this foot pedal. And when I click the foot pedal, the stepper will spin 20 turns, or a little bit over 20 turns, and then back out a little bit over 21 turns, so that it runs the thread gauge through the parts and then back out. And I'm going to demonstrate that